Okay, this is going to be just a really informal, God help me, video talking about the ins and outs of the instrument, a little bit of maintenance things, some of the boxes here regarding the instrument, and things like the shunt wrench, got some fuses, this little metal, almost looks like a tiny little stick, Q-tips, things like that. So we're going to go over the basics behind the NMR instrument. One of the first things, just to go over it here, this is the air pump, okay? And all that this thing does is pump air into our NMR so that we can use it for spinning our samples. So the first thing about this is, somewhere in the back here, you'll see that the switch is right there, the on-off switch. So you can just grab that, turn that on, and it is fairly noisy. You only need it, and that's why it's sitting on this foam, a heavy piece of foam. Cuts down on the vibration and the sound. As soon as you're done collecting your sample scan, you don't have to keep this running if you're processing it. But I mean, during a lab, most of the time we just leave it running, that's fine. This pump can be turned on and off at will without hurting the instrument or affecting your scan of a sample, anything like that. The one interesting thing about this little device is right here, it looks like a keyhole, but it turns out all you need is a sizable enough screwdriver to open this side panel. I'll show you that. So in the box, which at the moment is the box of materials that we first got with the instrument, so we just happen to leave everything in here, and it's usually in one of these two drawers. That's where we keep it. So you take out this screwdriver on the end, and you just put it right in here, and we'll turn that, and it should open. So you can see in here, that's the pump, and this is the case it's in. There's a lot of this plastic tubing, and sometimes what had happened before, I'm trying to find the exact culprit here, but it looks like we're okay. It was this one right here. You can see how, come on, focus. Right there, you can see that copper wire. This one connection didn't have one of these plastic tightening things, and you can see even this doesn't. This kept coming off, and as soon as it did, we lost our air to do the spinning. The other thing is, somewhere in here, and it shows in the manual, there is a sight in here for a fuse. So if for some reason this does not electrically operate, right, so let me just close this up to keep it from springing open. So I'll go back to tightening that. There we go. If for some reason that pump does not turn on, you can see these mixture of fuses here. So I'll get a shot of this. This one says the main chassis, and I'll show you that. That's part of the FTIR magical box. See how it says 4 amp, right? And there's those ones. This one is the air source. So this is the 6.3 amp fuses for the air pump that I was just showing you guys. And then this one here, 2 amp fuses for the magnet temperature controller. Okay, so these are the fuses in the box. So if for some reason, whether it's the temperature or this is called the chassis right here. It's the magical box, if you will, that handles a lot of the data and the FTIR. So normally you would get some sort of prompting on the screen if a fuse in here went, or inside here the temperature control went, the fuses for that. So anyway, that's the air source. Now normally kind of rotate this a bit, push it towards the wall a little bit. The other thing I want to get out of the system right now is this. Right inside here there's a piece of foam, and they use that for insulation to keep this at a certain temperature. Once a year or every other year, you might have to do what they call a shunt, S-H-U-N-T, a shunt adjustment, or they say shunt this. You need super long, huge, almost like 13, 14 inch tweezers to reach in there and pull out the foam and set far enough back in there. There's a tiny flat-headed screw adjustment, and that's what this here is for. This is the shunt wrench, they call it. So what you're going to do is, once or twice a year, if you have to readjust this magnetic field, there's a procedure inside the manual that walks you through it. The only hard part is understanding that right here, you pull all that foam out. With a flashlight, you can make out where the end of this is going to go. and you can slowly make the adjustment that the procedure requires you to do. But like the gentleman said, sometimes people will go 2-3 years without even having to do a shunt adjustment on this whatsoever, okay? So that covers that. This thing. You can see that what we're going to do is you take one of these Q-tips, you sharpen the end enough that you can stick it firmly inside this. So basically at the end of this, you would have a Q-tip. And the whole point of that would be, and it's in the manuals as well, if for some reason you're having some trouble spinning your sample, the idea would be to go inside this probe, way down there, okay? And at the bottom, you would very lightly, with a Q-tip attached to this, so you'd have this Q-tip, and you would slowly, with acetone, you don't want to drop this in there, you want to be able to retrieve it, hence that long metal tube. With a little bit of acetone on this Q-tip, you could just, way down there, right, you would lightly clean this by going up and down like this with acetone. I'm only doing this so you can see it, but you would be rubbing with a little bit of acetone way down on the bottom, okay? Sometimes that can remove any kind of buildup of oils off our fingers or something like that to help the spinning process. So that's what these Q-tips are for. Some of these other screwdrivers are for adjustments that the manual can walk us through. Inside this box, right in this paper towel, is another spinner. So in this drawer, normally I have the paraphernalia, such as the NMR tubes. We have new tubes, the lids. We have the sealed standard samples that came with the instrument, and I'll show you those later. But this, sitting in its nice little home, this is our plastic spinner, okay? We have another one just like this, carefully wrapped up in paper towel and left there in case we only ever need it. As long as this works, this is like gold, right? We can send these back to the to be refurbished. So even if on the inside of this you see that orange, it's almost like an O-ring that holds the tube. So I imagine every 1 or 2 years we'll have to send these back to get them refurbished, and they come back to us, but we do that with the company. But that's our spare. Okay, so that's this drawer. We have yet another one here, which has these laminated from the manufacturer. This is the instrument setup guide. This guides us talking about spinners and things like that. But we have the actual manual, which is a big bug killer, but it has lots of information there should we need it. So that covers the air source. We're talking about this. I'll just walk us through this real quick. This right here is the probe that our sample will ultimately get put down. This button right here is actually the volume of air coming from this pump that goes down into the probe. So if you turn it clockwise, I do believe you get more airflow. So let's say that you had your sample sitting down there, and you can see by eye that it's sitting at roughly the level it should. If you turn up the air too much, your air, the air will push your sample up higher, which is no longer down on the probe where it should be. Sometimes this has to be slightly adjusted to make a sample spin nicely versus not, but you don't want to have too much air because it'll essentially eject your sample whether you like it or not. Rarely ever touch that. This knob here is part of the instrument setup when you do a certain standard test. So for normal sample running, we never ever touch this one either. Okay, that's only used for instrument setup type procedures. These two buttons right here, yes. This one right here, when we flip it up, it stops a sample from spinning. When we flip it down, the sample, if it's down at the bottom, will spin. So this is spinning on and off. This little button, which you can barely make out, right there in the corner, that is the eject button. So basically, and normally my rule of thumb is I always like to leave the spinning on because it redirects the air in such a way that if the sample was put in here, it would stay floating at the top. When you flip this, it redirects the air so that it drops slowly to the bottom. And once it's at the bottom, when you flip this back down, it starts its spinning when it's down there. So normally, when in doubt, I always like to leave the spin on if I'm going to eject. When you press this button, the NMR sample can sometimes come up as high as 12 inches above this. So if you're sitting over top like this without glasses on, for instance, you know, it can come up and poke you in the eye. So normally what you do is you put one of your free hands over the top like that and press eject, and then you'll catch it. Okay, so that handles those two buttons. And as far as the other things to point out, this little thing right here is nothing more than to take your NMR tube to make sure that you have the proper depth on that. So I'll demonstrate that when we run a sample. This here is the, like I said, the magic black box. We normally do nothing with this. And then this is the computer on down below. And I'll take us through the computer when we actually run a sample, okay?